Hi everyone, welcome to IT Projects Ideas. Are you tired of manually adjusting your home thermostat to maintain a comfortable temperature? With this project, you can build your own Internet of Things IoT temperature control system using the ESP8266 microcontroller, the DS18V20 temperature sensor, and the Blynk app. We previously built a temperature controller with ESP8266 web server. Many of you liked it, but it lacks some features like controlling over the internet. Should be on the same Wi-Fi network to control the device remotely. It cannot store the state of the system in EEPROM, so the system cannot retain its settings when there is power failure. So this project is upgraded with many useful features like monitoring and controlling your system remotely from anywhere in the world using Blynk IoT. Storing the state of the system in the EEPROM of ESP8266, allowing the system to retain its setting even when the power is turned off. With this project, you will be able to set a temperature set point and a
hysteresis values.
to maintain a consistent temperature within a certain range. You can also switch between automatic and manual mode, allowing you to control the heating and cooling relays directly using the Blynk app. To build the system, you will need ESP8266 microcontroller, DS18B20 temperature sensor, 0.96-inch OLED display, 2-channel relay module, few jumper wires, 0 PCB or breadboard. Now that we have all of the materials that we need, let's start by setting up the hardware. First, connect the OLED display to the ESP8266 using I2C, SCL and SDA pins. Next, connect the DS18V20 Dallas temperature sensor to the ESP8266D7 pin. Add a 4.7K ohm resistor between DQ and VDD pin. Then, connect the 2-channel relay to the ESP8266D5 and D6 pins, while VCC is connected to the VIN pin for 5V power supply. Connect all GND pins to GND and VCC or VDD pin to 3.3V pin of ESP8266 module.
To avoid messy wiring and give a clean look to the project, you can also order a custom PCB from PCBWay.com. We have already designed a custom PCB for this project, and you can download and upload the Gerber file to their website.
Now we have set up our hardware. Let's move on to setting up the Blynk IoT dashboard. In order to monitor and control a temperature controller from Blynk IoT server, you first need to set up the Blynk IoT Cloud dashboard. To set up the Blynk server, visit blynk.cloud. Create an account or simply sign in if you created the account earlier. Here, we need to create a new template. Enter a template name. I'm giving it a IoT temperature controller. Select the hardware board ESP8266. The connection type will be Wi-Fi. You can add a description of your project if required. Click on Done. Now the template is created. Creating new Blynk data stream. In our project, we are monitoring 7 parameters. So, let's create a new data stream with a virtual pin. Provide a name to the data stream. Select pin, data type, units, maximum and minimum value, default value, etc. Then click on Create. Similarly, create other data streams with virtual pins V1 to V6. Follow this video to create and set up all 7 data streams. I have selected V0 to V6 pin respectively for our 7 data streams. The variable data type is double for current temperature, set point, and
hysteresis values.
Integer data type for buttons and string for text display. The maximum value for current temperature and set point is 50 degrees Celsius. For
Hysteresis,
the maximum value is set to 5 degrees Celsius. The default value is set to 0 for all data streams. Design the Blynk 2.0 web dashboard. After that, move on to the web dashboard. In this section, you will be able to see some widgets for making your cool looking web dashboard. We will use only the free widget available. To display text, I am using a label widget. For showing the value of current, temperature set point, and hysteresis, I have selected gauge. Similarly, switch widget for automatic mode, heater and cooler on or off buttons. Finally, slider widget for set temperature and set hysteresis. In the settings of each widget, you have to give a name to the widget and you have to choose the data stream with which the widget will be connected. After setting up the widgets, click on the Save button to save the entire project. Now, your web dashboard is finally ready. Using this web dashboard, you can monitor and control your device. Adding new device. Let's add a new device. For that, click on the search icon. Click on Add New Device. Select the first option, that is from Template. Choose your template and give a device name, then click on Create. A new device will be created. You can see a snip of the code header file appear on the dashboard. Click to copy it. Now you can paste this template ID, device name, and authentication token to the program code. That's all for setting up the Blynk IoT dashboard. We will set up the Blynk mobile dashboard after uploading the program code. Code or program. This is the program code for IoT temperature controller with ESP8266 and Blynk 2.0. You can find this program code explanation, Blynk setup guide, and circuit diagram on our website. I will attach the link in the description. You can install the required library from my previous video. Apart from this, update the Wi-Fi SSID and password from here. After necessary customization, it's time to upload code to this ESP8266 Node MCU development board. So go to Tools Board, ESP8266 Boards, Node MCU 1.0, ESP8266 12 module. Then choose the correct COM port. Finally, hit that upload button. It takes a few seconds to compile and upload the code. You now have a working temperature control system that you can access and control remotely from anywhere in the world. Now let's set up the Blynk app for mobile. Download the Blynk application into your mobile. After installing the application, log in into your account. You will see a new device IoT temperature controller. Click on it and start configuring the mobile dashboard. As done on the web dashboard, I have used one label widget, 3 gauge widgets, 2 slider widgets, and 3 button widgets. So that's all for the mobile dashboard setup. Now you can see the data of your Blynk device into your mobile app and in the web dashboard as well. Here is a demonstration of how this IoT temperature control project works. The ESP8266 microcontroller connects to a Wi-Fi network and then Blynk app, allowing the user to control and monitor the system remotely from anywhere in the world. The ES18V20 temperature sensor measures the ambient temperature and sends the data to the ESP8266. The OLED display will show the device name and other information about the system, such as the current temperature, set point,
hysteresis values,
and modes. The user can set a temperature set point and a
hysteresis values,
using a slider on the Blynk app. The system can operate in either automatic or manual mode depending on the user's preference. In automatic mode, the system will compare the current temperature to the set point and
hysteresis values
to determine whether the heating or cooling relays should be activated. If the current temperature is below the set point minus the
hysteresis values,
the heating relay will be activated. If the current temperature is above the set point, cooling relay will be activated. If the current temperature is within the set point plus or minus the hysteresis value, both relays will be deactivated. You can also see the real-time feedback on the dashboard. The system also uses the EEPROM to store the state of the system between power cycles, allowing the system to retain its setting even when the power is turned off. And that's it. With a little bit of coding and some basic electronics skill, you can build your own IoT temperature control system using the ESP8266, the ES18V20 and Blynk app. Thanks for watching and happy building!